Moss, a plant that is so underrated that it is slowly being neglected by us.
Whenever we think about moss, the first thing that comes into our minds is a patch of green and useless, disgusting plant which grows at the side of drains or even rotting logs, for example.
But that is not the case, as moss is actually more useful than we think.
And today, we are going to change your minds.
Hello everyone, my name is Joby.
And I'm Dash.
And in today's video, we are representing KMKK to talk about the benefits of growing moss.
Firstly, do you know that moss is very good at cleaning air? Moss is classified as bryophyta in the plant kingdom. It has a very unique structure and bacteria lives in between the spaces of the moss. The bacteria will convert dust and chemicals that are collected by the moss from the air into biomass. This is what's called mutualism between the bacteria and the moss. Hence, moss is actually more effective than common house plants like Sansevieria in cleaning air. Now let's take a look at the experiment that we conducted.
So, in this part of the video, we are going to do an experiment to compare the effectiveness of moss and Sansevieria in absorbing carbon dioxide gas. First off, we have here calcium carbonate. In this case, we are using seashells, which we are going to use to put into our hydrochloric acid to produce our carbon dioxide gas. Now, this carbon dioxide gas is going to flow through this bottle which contains water. Now, what water is going to do is it's going to neutralize any excess acid that may flow through this tube. And we don't want acid flow through our gas chamber to destroy our moss. We only want carbon dioxide gas. That's why we put water here. And of course, the carbon dioxide from this water bottle is going to flow through our gas chamber which contains our moss samples, which is right here. Now, this gas chamber is going to contain all the carbon dioxide gas which our moss is going to absorb completely. From this gas chamber, the excess carbon dioxide gas is going to flow through this outer tube into this jar which contains lime water, which can test the presence of carbon dioxide. And of course, this is our Sansevieria sample. So, to start off, I'm going to make sure our lid is closed tightly and everything is set up correctly. And then I'm going to add our calcium carbonate into our hydrochloric acid. I'm going to add a few pinches of our seashells into this hydrochloric acid. As you can see, as I'm adding the seashells into the hydrochloric acid, the hydrochloric acid has started to have a reaction with our calcium carbonate. And I'm going to close this tube. Now, as you can see, the carbon dioxide gas is starting to flow through our gas chamber and out into our lime water jar. Now, as you can see, our lime water is starting to turn cloudy, which proves that this is indeed carbon dioxide gas flowing through our gas chamber. And what I'm going to do now is I'm going to stop the flow of carbon dioxide. And I'm going to unscrew this cap. So what we're going to do is we're going to leave this gas chamber for 30 minutes to let the carbon dioxide be totally absorbed by our moss. And after 30 minutes, we're going to test for the presence of carbon dioxide again. See you in 30 minutes. So now 30 minutes have passed. And now what I'm going to do is I'm going to unclip this tube. And now I've already changed the new set of lime water. And what I'm going to do is I'm going to use this air pump to pump any gases left inside this gas chamber into this jar. Now, as you can see, the lime water remains clear because all the carbon dioxide gas has been absorbed by our moss. Now, let's repeat our experiment with Sansevieria. So now, let's take a look at how Sansevieria absorbs CO2. Now, I've replaced the moss samples in the gas chamber with our Sansevieria leaf. And I'm going to repeat the same process with moss on our Sansevieria. I'm going to put our calcium carbonate into our hydrochloric acid. As usual, the reaction starts to happen. Now I'm going to close this lid. Now, as you can see, carbon dioxide is starting to flow into this gas chamber and into our lime water again. As you can see, the lime water, which is clear just now, has turned cloudy. This proves that there is indeed carbon dioxide flowing through this gas chamber. Now I'm going to stop the flow of carbon dioxide. And I'm going to remove our hydrochloric acid lid. Now, as usual, we are going to wait for 30 minutes to let our Sansevieria absorb the CO2. Let's see how our Sansevieria compares to our moss. So, we are back. 30 minutes have passed since we left our Sansevieria. And now I'm going to repeat the same process as we did with moss. I'm going to unclip this tube. I've changed this lime water into a new sample, which is clear. And I'm going to use this air pump to pump the remaining gases into this lime water jar. Now, as you can clearly see, our clear lime water has turned cloudy. This proves that the Sansevieria has not completely absorbed the carbon dioxide, which causes the lime water to turn cloudy.
From the experiment above, we can infer that moss is more effective than Sansevieria in absorbing carbon dioxide. But why? Take a look at these samples. Moss have very unique cell structures. We can't see a single nucleus even when put under a 4 times microscopic lens. This proves moss has more cells than Sansevieria leaves, as its cells can be clearly seen in figure 1. Due to the larger amount of empty spaces, moss has more surface area to undergo gaseous exchange. More bacteria is also able to live inside the moss to convert harmful substances into biomass.
Another thing about moss is that it is very easy to grow than other plants. Firstly, you can easily grow moss by spreading some of it on some dirt. It will reproduce and eventually provide you with a fresh patch of moss. And moss also requires less sunlight, thus you can grow it indoors. Moss also requires less maintenance, as you don't need to trim it and you don't need to water it as often. This makes moss a very good choice for people who like gardening but do not have the time to maintain it.
Well, this concludes our research on moss.
Therefore, we recommend people to switch to moss as common houseplants.
This will not only add greenery into your homes,
but most importantly, it will provide you with cleaner air in your houses.
Thank you for watching.